Section 8-4, Comparing Two Linear Functions. Part 1. The graphs of two linear functions intersect if the functions have different rates of change. Remember, rate of change is your slope. So if two lines have different slopes, then they will intersect. So let's look at these two examples here that's been provided for us. Looking at this first graph here, this line has a positive slope. This line has a negative slope. Therefore, they intersect at this point right here. Okay? Now, we could determine the slope of this line by looking at this point. They rise one, run one, rise one, run one. Therefore, the rate of change for this line is 1. 1 over 1. 1 over 1 is positive 1. Then we have this line. It's going downward. It has a negative slope. Find a distinct point. Passes through the origin, passes through exactly that point there out at 4, negative 1. So to go, your rise would have to be negative 1. We would come down negative 1 and run 1, 2, 3, 4. So your rise is negative 1, your run is positive 4, giving you a slope of negative 1/4. So these lines have different slopes, therefore they meet at a specific point. Same situation with these two lines. They meet at a specific point because their slopes are different. The slope of this line is 1/3, rising 1, running 3. From here to here, finding those perfect points, rising 1 over 1, 2, 3. So rise 1, run 3, gave this line a slope of 1/3. Looking at this line, it has a slope of positive 2. Let's find a perfect point. Here's a point and here's a point. You had to rise 2, run 1. Rising 2, run 1. So 2 over 1 would be a rate of change is 2. So if lines have different rates of change, then they will intersect at one specific point. Let's look at this example. Here, for each city, we're comparing rates of change of a linear function. For each city, there is a linear function that describes the temperature in degrees Fahrenheit in terms of the number of hours since 8 o'clock a.m. Which function has the greatest rate of change, and what does that mean in this situation? Okay, so we're comparing rates of change of linear functions. All right, we have 3 cities that have been listed here. Eastbury, at 8 o'clock a.m., the temperature was 62 degrees. And between 8 o'clock and noon, the temperature increased by 3 degrees Fahrenheit per hour. So our Q numbers it started at 62. The temperature at 8 o'clock was at 62. But between 8 and noon, it increased 3 degrees. That was Eastbury. All right, let's look at Toppersville. With Toppersville, we have an equation where T is the temperature in degrees Fahrenheit and H is the number of hours since 8 o'clock. Well, what's going to happen every time you plug in? All right, so at 8 o'clock, H would be 0. At 8 o'clock, H equals 0. At 9 o'clock, H equals 1. All right? So we could look at that. We could determine some points. So if we plug in H is 0, we'd have T is equal to 54 plus 2 times 0. Well, 2 times 0 is 0, plus 54 would be 54. So the point 0, 54 would be the initial value or your y-intercept. Now if we plug in 1, T equals to 54 plus 2 times 1. Well, 2 times 1, multiplication first. 2 times 1 is 2. What is 2 plus 54? That would be 56. So you see, if I went on and let went to the 10 o'clock hour. At 10 o'clock, that would be 2 hours since 8 o'clock. So if I plugged in 2 for H, that's 2 times 2 is 4, and 4 plus 54 would be 58. So you see, we're increasing by 2. This 2H says we're increasing every hour by 2. Okay? So Eastbury started at 62, increasing every 3 degrees every hour. And Toppersville, they started at 54. And they're increasing by 2. Now let's look at Hilltown. Hilltown was given to us in a table. At 8 o'clock, we were at 62 because we went back to our problem. Our original problem said hours since 8 o'clock. So that's where everything begins. So at 8 o'clock, it was at 62. At 9 o'clock, 64. You see we had an increase of 2. From 9 to 10, we had another increase of 2 to 66, increase of 2 to 68 at 11, and on to 12 o'clock noon, increase of 2. So this one has a rate of change of 2. So your rate of change would be 2. Okay? All right. So looking at this problem, let me just kind of summarize it for you. Eastbury started at 62 degrees and increased 3 degrees Fahrenheit every hour. This is per hour. Okay? Then Toppersville started at 54 degrees and increased by 2 degrees Fahrenheit per hour. Just kind of summarizing for us. And then Hilltown, coming from our table, at 8 o'clock it was 62 and it increased 2 degrees Fahrenheit per hour. Okay, so I think we determined the rate of change. This would be your rate of change, what it was increasing per hour. And let me also say that this is your initial value. This is what it was at 8 o'clock. 0 hours after the time started, 0 hours would mean the initial time, what it was when it first started. So this column is your initial time, this column is your rate of change. So which one had the greatest rate of change? It would be Eastbury. Eastbury had the greatest rate of change. I'm going to write that to the side. It had the greatest rate of change because its rate of change was 3 degrees per hour. Toppersville and Hilltown had the same rate of change, which was 2. You can look at that as 2 over 1 if you want to. 2 over 1, 3 over 1. Now, what does that rate of change being the greatest mean? It means that Eastbury, the temperature is warming up faster than Toppersville or Hilltown by having the greatest rate of change. Eastbury is warming up faster than in Hilltown or Toppersville. Now again, we've already decided on the initial value. What was the degrees at 8 o'clock? That was your initial value. It was 62 when we first started at Eastbury, 54 at Toppersville, and Hilltown was 62 also. Okay? So if I ask you to compare the initial values of the temperature functions for the 3 cities, we see that Eastbury and Hilltown had the same initial value, and Toppersville was less. All right, what do the initial values mean in this situation? Well, we can subtract the 2 because there is a difference between the two. We got 62 minus 54 would be 8. Now 62 is for Eastbury and Hilltown. And then the 54 is the Toppersville. So at 8 o'clock a.m., it is 8 degrees Fahrenheit warmer in Eastbury and Hilltown than it was in Toppersville. So that's what the initial value really means. At 8 o'clock, it was 8 degrees warmer in these two cities that had the 62 and the 62. It was 62 degrees warm. It was 8 degrees warmer in Eastbury and Hilltown because it was 62 degrees, and in Toppersville it was 54.